Alright, welcome to Day 2 notes from Chapter 1A. Today we're going to talk about some applications of the linear equations that we talked about solving yesterday. So before we start, let's review some of the formulas that you know from geometry, specifically for a rectangle. So we've got area of a rectangle. You can remember that formula as either length times width or base times height. Either one. I'm going to keep it length times width for now, a little bit easier to distinguish in some of the word problems. We also have the volume of a rectangular prism, which means you have a rectangular base. To find that, you're going to do the length times width times the height. Length times width would account for the area of the base of the rectangle, and then times the height because it's volume. And then we've got perimeter of a rectangle is going to be 2 times the length plus 2 times the width. Alright, so that kind of reviews rectangles. We also have area of a circle. Hopefully you remember that one is good old pi r squared, even though we know they're round. Haha, it's a joke. Alright, then we also have the circumference of a circle is either pi times diameter or 2 pi r. You can remember it either way, it doesn't matter. Okay, and then just in general, we have the volume of a prism. A prism is a shape that has 2 bases. So it would be like a Kleenex box, basically, or a soup can, something like that. So to find the volume of a prism, where you've got 2 bases that are parallel, you're going to do the area of the base times the height. So hopefully in geometry you did this the same way, but big B, capital B, stands for the area of the base. If we're talking about the volume of a pyramid, that only has 1 base, then you do the formula 1/3 the area of the base times the height. And then while we're talking about it, also surface area of prisms and pyramids. Surface area for a prism, we've got 2 parts. You've got your lateral area, which is going to be the perimeter of the base times the height. And then you've got your total area as the area of the bases plus the lateral area. So just a little refresher there. We won't use every single one of these formulas, but hopefully that jogs your memory back to geometry a little bit. Hopefully not too many bad memories there. Okay, so let's go ahead and try some of the Algebra 2 problems that you're going to see that use these geometry formulas. So it says, I fenced in my yard with 298 feet of fencing. If my rectangular yard has a width that is 1 less than twice its length, what are the dimensions of my yard? So I like to start these problems by writing down what I know. I fenced in my yard with 298 feet of fencing. It means that the perimeter of the yard is going to be 298 feet. Then it tells me that the width is 1 less than twice its length. So what I'm going to write for width is 2L minus 1. Now, sometimes people get confused and want to write 1 minus 2L, but what I say to that is if I asked you to take 5 less than your age, you would start with your age and then subtract 5. So whenever you see that word less than, you need something else to start with. Usually it's the variable. Okay, so this is a perimeter problem. If you would rather draw a picture, you certainly can. Doesn't really matter where you put your W's and L's. But we, as we went over up above, know that the perimeter of a rectangle is 2L plus 2W. So now this basically becomes a substitution problem. We know the perimeter of the rectangle is 298. We know that the width is equal to twice the length minus 1. So I'm basically going to do substitution. 2L plus 2 times, here's the substitution, 2L minus 1. Now you've got this all in terms of one variable, so you can just go ahead and distribute, combine like terms. So we've got 6L is 300, divide by 6, so I get that L is 50 feet. And then to find W, I'm just going to plug that in. So W is 2 times 50 minus 1, 100 minus 1 gives me a width of, this gives me a width of 99 feet. Alright, now let's look at number 2. The second question says the surface area of a box below is not known, but if its length is decreased by 2, its surface area becomes 118 feet squared. What is the length of the original box? Okay, so this problem is asking us to deal with surface area of a rectangular prism. So when we're thinking of surface area, we have the area of the bases, which there's 2, the top and the bottom, and we have the lateral area, which you find by doing perimeter times height. So basically our formula for the area of this box is perimeter times height plus 2 times the area of the base. Now, even though we don't know what the original box dimensions were or the total area, it's interesting, and I think it makes it easier if we start by thinking about, look at the original box. What would its surface area be? So the perimeter of the base, we've got one L here, another L in the back here. Then we've got 3 and 3. So basically our rectangle base right now is looking like this. L, L, 3, and 3. So the perimeter of the base is going to be 2L plus 6 times the height, which is the part that connects the bases, that's this part right here, which is 5, plus 2 times the area of the base. The area of the base is L times 3, so 3L. We can simplify this if you want to, so you could get the original area of the shape would be 10L plus 30 plus 6L, which simplifies to 16L plus 30. Now, what the problem is asking us to do is it's asking us to consider, what about if the length is decreased by 2? So our new base looks like this, L minus 2, 3, 3, and L minus 2. So in our new shape, we know the surface area equals 118 feet squared. Our perimeter of the base, L minus 2 plus L minus 2 plus 6. I'm going to write it 2 times L minus 2 plus 6 times the height, which is still 5, plus the area of the base, which is now 3 times L minus 2. So now I'll do some more simplifying. So I've got 2L minus 4 plus 6 times 5. That parenthesis is going to simplify to 2L plus 2 times 5. And then for the area of the base, I've got 2 times 3L minus 6, which is going to give me 6L minus 12. So now one more distributing, 10L plus 10 plus 6L minus 12. I've got 16L minus 2 equals 118. I'll add the 2 over, so 120 equals 16L. Divide by 16, and I'm getting that the length is 7.5 feet. Even though I didn't ever have a width, that's all I needed to find. It's asking me for the length of the original box. So I found that this L is the length of the original box, 7.5 feet. Alright, another kind of word problem that you're going to see tonight isn't so much involving geometry, but it's involving motion. So we need to review the formula distance equals rate times time. Of course, within this formula, we can also solve for different variables. Like we could say r is d divided by t, or t is d divided by r. But the one that you're going to use most often is the first one, distance equals rate times time. In case you forget, d stands for distance, r stands for rate, and t stands for time. Okay, now, it's not going to be quite as simple as just distance equals rate times time most of the time. If we're talking about a problem with just one person, then it will be that simple. Distance equals rate times time. If we're talking about two people, then we have to consider, are they traveling in the same direction or opposite directions? if they're traveling in the same direction, the picture that I usually draw looks something like this. And usually you're trying to find the distance between them. So what you're going to do is actually subtract their distances. If we have people that are traveling in the opposite directions, then I usually draw my picture more like this. And to find their distance between them, we're going to add their distances. So same, subtract, SS, opposite, add, OA. I usually say variable O, or variable, vowel O goes with vowel A. Just a little memory clue there, not a big deal. Same direction, subtract, opposite direction, you're adding. And keep in mind, if they are traveling the same distance, then rate times time is going to equal rate times time. Okay, let's go ahead and try some of those problems. Okay, so our first motion problem says, I am driving to my aunt's house 192 miles away. So far I know that the distance is 192 miles. If I average 60 miles per hour, that's a rate. About how long will the trip take? So that's a question of time. Now this is just one person traveling, so this is going to be a pretty straightforward one. Distance equals rate times time. We know all of the variables except for t, so just plug in 192 is the distance, equals 60t. We can just divide by 60, and we get that t is 3.2. Now, keep in mind your units. Since our units for the rate was miles per hour, this time is 3.2 hours. Now, let's talk about 0.2 hours for a second. Does 0.2 hours mean 20 minutes? No. Does 0.2 hours mean 2 minutes? No. 0.2 hours actually means that you have to multiply 0.2 by 60 minutes, which gives you 12. So if I asked you more specifically how long this was going to take, you would answer 3 hours and 12 minutes. So just keep that in mind. Please don't look at 0.2 and think that it means 20 minutes. It's 0.2 of an hour. There's 60 minutes an hour, so 0.2 times that equals 12 minutes. Alright, question 2 says, my aunt and I decide to meet somewhere in between our houses. She always drives 10 miles per hour slower than I would. If it took us 2 hours before we met up, what was our average speed on the trip? Now, we do need to borrow some information from the previous problem. This is still a problem about you and your aunt. Here's what we know. The distance between your house and your aunt's house is 192 miles. You're starting from one end, your aunt's starting from the other. So you're going opposite directions, but towards each other. Let's think about each person. So you've got you. Your time that you're traveling was 2 hours, and your rate was whatever your rate was. For your aunt, she also traveled 2 hours, and her rate was 10 less than yours, so hers was r minus 10. Now total, you guys have traveled 192 miles. So when we write your equation, we're going to take your aunt's rate times time, because that's going to give us her distance. So r minus 10, rate times time, which was 2 hours, plus your rate times time is going to total to your total distance here, 192 miles. So now we're just going to distribute 2r minus 20 plus 2r is 192. Variables to one side, numbers to the other. Divide by 4. So we get that r is 53 miles per hour. Now, really important in a word problem is to look at what this answer means. R, remember, was your rate. So the question is saying if it took us 2 hours before we met up, what was our average speed on the trip? So your rate was 53 miles per hour. Your aunt's rate was 53 minus 10, which is 43 miles per hour. Alright, now we get to go to a totally new question. This one says, Lynn left the house in the morning to go to work at the mall. Because of traffic, she only averaged 40 miles per hour. So I like to kind of start it off. Lynn, her rate was 40 miles per hour. Bill left later to go to the same mall, and since the traffic was lighter, traveled 60 miles per hour. So his rate is 60 miles per hour. And it took him half an hour less. How far is it from their house to the mall? So they're traveling the same distance because they're both leaving from the same place. Lynn's distance equals 40 times the time that she traveled. Bill, his distance is going to be 60 times the time that he traveled, which was half an hour less than Linda. So I'm going to write his as t minus 1/2. Now again, because they're both starting at the same place and driving to the mall, their distances are going to equal each other. So I can go ahead and write my equation as 40t equals 60 times t minus 1/2. So now I'll just go ahead and distribute. 60 times 1/2 is going to be 30. Variables to one side, numbers to the other. And I'm going to get t is 3/2 or 1.5 hours. Now the question says, how far is it from their house to the mall? So answering 1.5 hours is not going to answer that question. This is just telling me how long Lynn traveled. So now to get the distance, I'm going to do 40, which is her miles per hour, times 1.5 hours. And I can figure out that the distance from their house to the mall is 60 miles. Alright, one more. Dustin just started jogging and can jog about 4 miles per hour. So again, I'll start off with Dustin. His rate is 4 miles per hour. His brother Luke has been jogging for longer and can jog at about 6.5 miles per hour. If they start off at the same time, going in the same direction, how long will it take for Luke to be 1 mile farther than Dustin? So for problems like this, I like to draw a picture just to illustrate what's going on. So this would be Luke out here in front. This is Dustin hanging out in the back. And we want to know, when is Luke 1 mile ahead of Dustin? So what we want to do on this problem is think about, how far has Luke gone? We don't know how long he's traveled, so we're going to let his time be t. So for Luke, we've got 6.5 t. That's his distance in this given amount of time. Now, they're going to be running for the same amount of time. We just want to know how long that is for Luke to be 1 mile ahead of Dustin. So Luke has gone 6.5 times t, that's his distance. I want this part to be 1 mile. So now, if I take Dustin's distance away, what I'm left with is going to be my 1 mile. So again, same direction, I'm going to subtract. Dustin, his distance has been 4 miles per hour for that given amount of time, and I want that distance between them to equal 1. So then from here, this is a pretty simple problem, just 2.5t equals 1, divide by the 2.5, and we would get that t is 0.4 hours, because again our rates were in miles per hour. 0.4 hours, it's good to convert that. 0.4 times 60 is going to give you about 24 minutes for Luke to be 1 mile ahead of Dustin. Alright, so that about sums up the Day 2 notes. Keep in mind, if you're traveling in the same direction, like in question 6, you're going to subtract their distances. If you're traveling in opposite directions, like we had in question 4, you're going to add their distances together to get the total distance. Good luck. I'll see you on Monday.